Welcome back. In Lecture 1, we examined how to build and run your first C# program from modern top-level statements to safe user input parsing. Now in Lecture 2 Part 1, Variables, Data Types, and Their Use Cases, we turn our focus to the very foundations of every application, how and where you store data, the different containers available, and when to choose each one. On screen you see today's session title, Variables, Data Types, and Their Use Cases in C#, Session 1 of Week 2. Over the next slides, we'll map out the storage options C# provides and their practical scenarios. Let's dive in. A variable is simply a named box in memory where you can hold a value while your program runs. Think of it as a label you stick on a container so you can store user input, temporary calculations, or pass data between functions. Giving each box a clear name makes your code more understandable and maintainable. We rely on variables for three main reasons. First, they let us store dynamic values, numbers, text, or true-false flags instead of hard-coding constants everywhere. Second, they improve readability. A well-named variable like username is far clearer than a stray string literal. Third, using variables means you only update one place if you ever need to change a value, saving time and avoiding mistakes. C# offers several primitive data types, each optimized for different scenarios. We have integer types for whole numbers, single and double precision floats for decimals, a high precision decimal for money, text strings, Boolean flags, and single characters. There's even a large integer type for very big counts. Picking the right type ensures your program runs both correctly and efficiently. The int type holds whole numbers from about -2 billion up to +2 billion. It is ideal for counting items, representing scores or identifiers, and indexing arrays. Remember, though, it cannot represent fractions, so it is not suitable for money calculations. The double type stores decimal values with medium precision across 8 bytes. Use it for measurements, like height or weight, and general scientific calculations. While you can approximate monetary values, avoid double in financial applications because rounding errors can creep in. A string is simply a way to store text, like names or file locations. Think of it as a container for characters. Now here's an important point. Strings in C# are immutable. This means that once you create a string, you can't change it. If you want to modify it, you have to create a new string instead. This might sound tricky, but it actually helps the computer manage memory more efficiently. So remember, strings are your go-to for handling any text in your programs, and their immutability makes them reliable and easy to work with. A bool variable is a special type of variable that can only hold one of two values, true or false. Think of it like a light switch that can either be on or off. You use Boolean variables to make decisions in your code. For example, you might check if a user is logged in by seeing if their authentication status is true. Similarly, you can validate if a form input is correct by checking if it meets certain conditions. Boolean variables are also useful for controlling loops and branches, allowing your code to follow different paths based on certain conditions. They help make your program smarter and more interactive. The char type is used to represent a single character, like a letter or a symbol. Think of it as a building block for text. For example, when you see options like Y for yes or N for no, those are characters represented by the char type. This is especially useful when you want to look at individual letters in a larger piece of text. Also, did you know that each character has a unique number in ASCII code? This helps computers understand and store text efficiently. C# also includes float for single precision, double for double precision, and decimal for high precision. Use float when you need speed and can tolerate lower accuracy, double for general decimal work, and decimal for precise financial or currency calculations. As a rule of thumb, always use decimal for money. When an int is not large enough, reach for long. It covers very large whole numbers, over 8 bytes, and works well for large counters or unique identifiers such as timestamps. A constant is a named value that never changes after you define it. You declare it using the const keyword. Common examples include the value of pi or your application version. Constants prevent accidental changes and signal intent clearly to anyone reading your code. First, let's talk about camel case. This means you start with a lowercase letter and capitalize the first letter of each subsequent word. For example, if you have a variable for a user's name, you would write it as username with capital N. Next is Pascal case, which is similar but starts with a capital letter. This is used for class names and method names like calculate total. Finally, for constants, we use all uppercase letters with underscores to separate words. For instance, max age is a great way to highlight important values. Remember, following these conventions helps make your code clear and easy to read. In this example program, we declare several variables, a student's name, score, grade point average, pass status, and letter grade, and then print each to the console. This simple demo shows how you combine multiple data types in a real-world scenario. Here are your key takeaways. Use int for whole numbers, use double for general decimals, use string for text. Use bool for logical flags. Use char for single characters. Use decimal for financial precision. Use long for very large integers. Choosing wisely will make your code reliable and efficient. At the end of this week's lab, you'll build a simple calculator. It will prompt for two numbers, perform addition, subtraction, multiplication, and division, and then display the results. This project will reinforce your understanding of data types and user input. In the appendix, you have a reference table of each type's memory footprint and range or precision. Keep this on hand when optimizing for performance or storage. And here is a code template you can use to practice declaring and printing variables of various types. Try it out to solidify your mastery of these fundamentals. That concludes today's lecture. In our next session, we will cover operators and type conversion, so you can manipulate and transform your data with confidence. Thank you for your attention.